Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. Coming to the problem statement, a square pyramid, 35 sides of base and 60 axis length, rests on HP on one of its slant triangular faces. Draw the projections of the pyramid when the axis is inclined to VP at 45 degrees. So, looking at the problem statement, we can make a certain set of conclusions. The first being the type of solid. So, the type of solid here is a square pyramid, which is measuring 35 sides of base and also having an axis of length 60 Next is the resting condition. So the initial resting condition is not detailed here, but however, it is very clearly mentioned that it is resting on one of its slant triangular faces. With this, we have to understand that it can be inclined on the HP on one of its slant triangular faces only when it is resting on one of its edges. So the resting condition will be it is resting on one of its edges. Next is the inclination with respect to the VP. So with respect to the VP, the axis is inclined at an angle of 45 degrees. So we are going to consider a parameter which has changed its length with respect to the given condition, that is the axis. So the axis initially it is 60 but whenever we take the second position it is less than the initial length of 60 so we are going to consider this particular parameter for inclination with respect to the VP, and obviously we have to construct the beta angle here. So now let us see how to draft the solution for this problem statement. So let us begin by selecting the line option from the sketching window, and let us draw a continuous line of thickness 0.18 and annotate the line as xy, and also annotate the reference planes. So now let us draw the top view of the square pyramid. So let us select the line of thickness 0.50 and then select the rectangle option and then complete it to draw the square. So the edge length measuring 35 and 35. So this is the top view of the square pyramid. So now let us draw the triangular faces, which can be done by joining the diagonals. And now let us select this particular annotation and annotate the corners. So let us tell that this is the corner A, and this is the corner B, this is the corner C, and this is the corner D. Also, this is the corner O, and inside the square bracket, this is the axis of the bottom face of the pyramid, which is O1. Now let us select the line option and then draw the projections from each of the corners. So that is from the corner B to A, and then similarly from corner C to D. And also let us draw the projection from the center intersect the XY line, and from this line we need to draw the axis which is measuring 60 So we shall select a line of thickness 0.13 and select the chain line. So from this point let us draw a line of length 60 which represents the axis of the square pyramid. And now let us complete the triangular view of the square pyramid in the front plane. So let us join this as two intermittent lines and join the apex. Let us annotate this. So this is the apex, which is O dash, and this is B dash, which is visible to the observer, and A dash inside the bracket, which is not visible, and this is O1 dash, and similarly here this is C dash and D dash. So this is the first condition. So in the problem statement, they have not told about this first condition, but it is very clearly understood that in order to complete the second condition, that is the square pyramid, which is resting on the HP on one of its slant triangular faces, we need to have the pyramid resting on one of its edges. Only then it can be tilted in such a way that the edge is the triangular face is resting on the HP. So now for this, let us select this pyramid, make it a rigid set. Now let us reselect the front view of the pyramid along with the annotations. And then let us move this, selecting the move option, ensure the copy is on. So now let us move this towards the right hand side of the XY line. Now let us select the rotate option, and this is the second point of rotation, and we are going to rotate it in such a way that it is resting on one of its slant triangular faces, and that faces BOA. So now let us just move this. Okay, so ensure all the annotations pertaining to the front view are in the vertical plane only. They should not be represented below the XY line. So now let us draw the projection lines of thickness 0.13 mm to get the top view of the square pyramid. So now we will complete this view. So we will select the line of thickness 0.50 and we'll begin from the corner A. Then this is the corner B, corner C, corner D, and back to corner A. So now we will just join all the slant triangular faces. So the farthest corner is the corner A. So from here, this has to be a hidden line. So let us just change this to a hidden line. And similarly, this will also be the hidden line. So for the observer, when he's looking from the top, so this bottom plate of the pyramid is completely visible, and this face is visible, and this face is not visible. So it will be a dotted line. So now let us annotate. So whenever you are doing the annotations, be careful. So it is A dash here. So this is A. So this is not A, this is C. So you have to be very careful because the edges is interchanged here. And next this is C, this is the edge D, and this is the edge C. Sorry, this is the corner C and this is the corner D. So now this is the apex O and this is the axis O1. So O01 dash O01 represents the axis. So use the trim option and trim the projection lines which is not required to be shown. So let us trim this line and make this an axis line. So by selecting a line of thickness 0.13 and then using the chain line, let us connect this and show this as the axis line. So now we can just extend this to next. Okay, so this completes the top view of the square pyramid. So now we have to consider this particular dimension, that is the initial length of the axis, which is equal to 60 mm, and then the axis in the distorted view, that is in the second position. So this is around 57.6. So this is the dimension that we require for constructing the beta angle. So now let us construct the beta angle. Let us draw a line of any arbitrary length. It should be a straight line. So from any arbitrary point, let us draw a line of length 60 mm, making an angle of inclination of minus 45 degrees. That is the given value, which is phi. And then let us try to draw the locus from the end point. And then select the arc by center point. And then from the same point, let us try to cut an arc which is having the radii of 57.6. So let us just try to cut an arc. So 57.6 will be the radii of the arc. So after this has been done, we need to join this point. So let us just try to cut an arc of 57.6, and then from the point of intersection of the locus line and the arc, extend this backwards to meet the point O. So this is the angle 45 degrees which is given to us, that is the angle phi. And from here till here, if you measure, this is the angle beta. So 56 degrees is the beta angle. So now we will construct a line in such a way that it is inclined to the VP at an angle of 56 degrees. So this is minus 180 plus 56. So if you just measure this, so this is 56 degrees. So now let us try to draw the horizontal and the vertical projections. Okay, so before that, let us try to incline this. So before we do that, let us select the pyramid and make this a rigid set. Okay, so it has to be done by trimming the lines, that is the projection lines. So for that, let us just try to delete this dimension and then trim this part of the projection lines, and then select the pyramid now. So we have to trim even this. So now select the entire pyramid along with the projections. Sorry, the axis line, and make this a rigid set. So now you can just redraw the projection lines by using the extend to next option wherever applicable. And then in some cases, you have to redo it. This is not a mandatory step, but however, whenever we are moving this pyramid, if it is not a rigid set, then there are chances that the pyramid or the prism, it will be moved in bits and pieces. It will not be moving as a whole entity. So that is the reason why it is better to practice making it a rigid set. So now let us select this. So select the axis line, which is very important because the axis is the one which is inclined. Select all the annotations. Now select the move option. Ensure the copy is on. So let me select O1 as the reference point and place this point O1 on the 56-degree line. Now let me go for the rotate option. So keeping O1 and O as the reference, let us try to incline this pyramid in such a way that it is inclined to VP on its axis. Now let us draw the vertical projections upwards. So the corner, sorry, the apex O is on the XY line, and A is also on the XY line. Corner B is also lying on the XY line. Corner C is here. Corner D is here. And then O1 is here. So using the trim option, let us just trim the projection lines which is not required to us for the construction. And now let us complete the front view of the square pyramid with its axis inclined to the VP at an angle of 45 degrees, but appears to be inclined at an angle of 56 degrees. So this is from the point A, corner B, and then corner C, corner D, corner A. So just join all the triangular edges, and then from here let us select a hidden line. So the farthest corner point is D, so obviously from D it has to be a hidden line like this. And now let us draw the axis line. So let us select the chain line of thickness 0.13. So from O1 to O, this is the axis. So let us annotate. So this is the point, the apex O dash. Similarly, this is the corner A dash, while this is B dash, and this is O1 dash, followed by D dash, and then C dash. So with this, we complete the drafting of the square pyramid, which is resting on the HP on one of its slant triangular faces. So as you can see that it is resting on one of its slant triangular faces, A dash, B dash, O dash. So this is how you can interpret the problem statement. So the condition of the edge condition resting initially is not given, but however the condition of the slant triangular face is given, so which has to be taken as a clue for placing the square pyramid on one of its edges. So let us select the leader option and indicate the direction of the projection lines. So with this, we complete the drafting of the